Okay. Today and tomorrow we are going to go over, maybe tomorrow, the two different types of sequences there are. Um, you should have gone over these at some point, either in geometry or algebra 2. I'm not sure if you actually did. So I am introducing them. We're not going to spend too much time on them. They are good to know, just in general, but they're not going to play a huge part in things that we do in the future. But again, I just want to make sure that you're aware of them, uh, what they are and what they do, and things like that. All right, so today we're going to look at two different types of sequences and series. Right, we talked about those in general last week. A sequence is just a bunch of numbers that in a row that we call terms. They may follow a pattern, they may not. And a series is when we add up the sequence, when we add up all the terms, right? And we had two types of series and sequences. We had finite, which means they end, right? And we had infinite sequences and series, which means they go on forever. So we'll go over both today, and right now I'm just going to kind of give you the definitions and parts that we need to know. So first, we'll deal with I pronounce it arithmetic. It might be arithmetic, but saying arithmetic sequence for me doesn't sound right, so I like to say arithmetic sequence. I may be wrong, but too bad, I'm the teacher. Okay, so an arithmetic and arithmetic sequence is when we have terms. I spelled differences wrong. So when we have our terms have the same difference between each term, right? So a basic way of thinking of it is if you can add or subtract a constant number, and that's what gives us our sequence. So a more mathematical definition, though, okay. So for our arithmetic sequences, we could say if the sequence A1, A2, A3, so on and so forth, is arithmetic, then there is a number D such that when you subtract a number and its previous term, then you always get that number D. Okay, and that number we call the common difference. Right, so if you notice pattern, and maybe it's like 1, 3, 7, no, 1, 3, 5, 7, 9, right? You can see that pattern that they're adding 2 to each, right? Well, then your common difference would be positive 2, and you would have an arithmetic sequence. Or it could be subtracting. Your common difference could be negative, right? So if you have 10, 7, 4, 1, negative 2, negative 5, then your common difference is negative 3 because you're subtracting 3 from both sides, from everything. All right. So we can take some of the properties of sequences and the fact that an arithmetic sequence has a common difference, and we can find the nth term, which means that we can find any term in the sequence, and it doesn't matter if we're given the term before. All right, so if I'm given, odd numbers, 1, 3, 5, 7, 9, and I want to find the 52nd term. Right? If you did that normally, and you did, all right, well, 1's the first term and 3's the second term, that would take forever. Well, we use some properties, some basic algebra properties, and we're able to find the nth term. So we're able to find any term with just a few things. So an is what we're looking for, and we can find it if we take the first term and we add to that the number of terms minus 1 times d. All right, and we'll go over some examples in a little bit once we get everything laid out. So we can find the nth term. And there's one more thing that we can do. Let me just underline this. We can also find a sum. Now, when we're doing the sum for arithmetic sequences, it has to be finite. Okay, there's no way that you can have a sum if you keep adding or subtracting the same number. Okay, if that goes on infinitely, right? So the odd numbers, 1, 3, 5, 7, 9, going so on and so forth. If I don't say that that stops somewhere, I can never add it up because it just keeps growing and growing and growing. All right, so So to find the sum of an arithmetic sequence with n terms, okay, we say S sub n. So whatever that term is, so if I'm looking for the sum of the first 10 terms, my n would be 10. I'd plug a 10 in there. And that's equal to the number of terms. So again, 10 for that example, divided by 2 times the first term plus the last term. Okay, so, and again, we'll go over that in a second. All right, so that's for arithmetic sequences. Arithmetic. GABA. All right, I'll come back to that if you need it. Now, geometric is similar. There's a pattern, but slightly different. Keep messing them up. Sequence. Okay, so geometric sequence is similar, but now it has a number r called the common ratio, where we would find the next term by multiplying by the common ratio. All right, so arithmetic is adding or subtracting if you're adding a negative number, and geometric is multiplying or dividing if you're multiplying by a fraction. Right, so I can go from 16 to 4 to 1 to 1/4 to 1/16 by multiplying by 1/4 or by dividing by 4. Okay, but if we're talking about geometric sequences, well, then I'd have to multiply by 1/4 because that's technically how we do it. All right, so R is called the common ratio. Similarly, we have a way to calculate the nth term. Oops. Using properties of multiplication. So we find the nth term by taking the first term and multiplying it by r to the n minus 1 power. So if I'm looking for the 20th term, I would take the first term and I'd multiply it by the ratio to the 19th power, right? N being 20, 20 minus 1 is 19. And again, I'll show you an example. If we don't have time today, we'll do it tomorrow. And also, we can find the sum. But now, you get some interesting stuff. So first we have the sum of a finite geometric sequence. All right, so the sum of a finite geometric sequence, and again, finite means that we stop, we end, is going to be the first term times the ratio of 1 minus r to the n power over 1 minus r. All right, so once you find that stuff out, it's just plugging it in and, calculating. Now, what's interesting about geometric sequences are, that's a tough grammatically. The interesting thing about geometric sequences are we can actually find the sum of an infinite geometric sequence. Okay, but with this, the absolute value of r has to be less than 1. Okay, so r has to be some sort of fraction. So it has to be 1/4 or 2/3. Okay, or negative. Okay, so that's why we use the absolute value. So if r is less than 1, then we can say that the sum, and I don't need an n now because it's an infinite sum. I'm adding up an infinite amount of numbers. And actually, it's a lot more simple. The sum is just the first term divided by 1 minus your ratio. All right, so we got a good bit of information here. Let me zoom out a little bit. And again, you should have seen some of this previously. Again, I don't know where. It's been a while since I taught either geometry or algebra 2, but if it's not familiar, it's not terribly difficult where you're going to be completely lost. But it does help if you know where we're coming from. What do we got? 10:50? Okay, we got time. All right, let's look at some examples. We'll start with arithmetic, and if we have time today, we'll get to geometric, but if not, we'll do that tomorrow. All right. Let's see. What do I want to do here? Okay. So we're going to kind of combine a bunch of this stuff together. So consider the sequence 1, 3, 5, 7, so on and so forth, dot, dot, dot. Okay, when you see dot, 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 that just means it keeps going on with that same pattern. I want to find the sum of the first 10 terms. All right, so first, what are they asking us for? Okay, they're asking us for what is S10? All right, so that's what we mean when I have the S with the little n, we replace the n with whatever that is. Okay, so again, that also tells me that my n is equal to 10. I'm looking for 10 terms. I want to find the sum of 10 terms. All right, so now there's a few things that you have to kind of think about. Well, first, is this arithmetic or is this geometric? So you say to yourself, do I add or subtract to get to my next terms, or do I multiply and divide? Right, well, it looks like if I do plus 2, plus 2, plus 2, that looks like it. That might fit, but let's think multiplication. Right, so I would have to multiply 1 times 3 to get 3. But if I do 3 times 3, that doesn't get me 9. Okay, so I'm going to write down here plus 2, plus 2, plus 2. So that's telling me we're dealing with arithmetic. And it's also telling me that my common difference, not R, my D is equal to positive 2. Okay, you don't need the positive there, but I'm putting it now just to show that we're adding. All right, so I can add that to the information I know. So now I want to find the sum of the first 10 terms. So let's plug in what we know. So let's do S10 is equal to 10 divided by 2. My first term, A1, is 1, plus, well, I need to find out now what is A10. Let me just say that this here, right, is our A1. Our first term is always that first number. So I need to find the 10th term now. Well, this isn't terribly bad. I can keep adding 2, right? 1 plus 3, right? I can keep going. But let's use my nth term here. All right, so let's see if I can scroll down just enough. That should be good. So we have to find A10. So A10 is going to be A1 plus 10 minus 1 times that common difference. All right, I just wrote the equation down here based off of what we have. So now let's plug everything in. So A10 is equal to 1 plus 9 times that common difference, which is 2. 9 times 2 is 18. 18 plus 1 is 19. So that's telling me my 10th term is 19. Okay, again, I didn't have to know the 9th term or the 8th or the 7th or the 6th. I used my formula to find that. So that's going to go up here. And we simplify. So I get 10 over 2 is 5. 1 plus 19 is 20. So the sum of the first 10 terms is 100. Right? And I can always double check with something like this. It's not too bad. All right, so if I do 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. Oops, no. Oh, that does get me 100. Okay, so you can check it if it's not too long. But if they ask you to find the sum of the first, 50 terms, that's too much, and I wouldn't, try it like this. But there we can see that we add up the first 10 odd numbers, it does get us 100. All right, so that was a bit much. I know we kind of threw a lot at you there. So we will go over some more tomorrow. We'll take a look at a geometric sequence and series. And then I'll answer any questions you guys might have. I am going to assign a quick homework tonight. It's just going to be on the basics of the arithmetic sequence. So I might ask you to find a common difference on the nth term. And maybe I'll do one of these for extra credit, but it's not going to be too crazy tonight. Since, you're just getting back into the swing of things since last week was just kind of a review and makeup week. All right, guys. So we'll continue with geometric tomorrow. Keep an eye out for an assignment tonight, and have a good day. I'll see y'all later.